Next, I'd like to introduce two of our MPC Alliance board members who play a critical role in the industry and in running the MPC Alliance. Dr. Dan Bogdanov has been a research team lead for multiple privacy technology research projects with DARPA, European FP7, and Horizon 2020. He is the co-author of multiple ISO and IEC standards on privacy and secret sharing, and he leads the Information Security Research Institute at Cybernetica. And in his spare time, he's a board member of the MPC Alliance. So thanks, Dan, for joining us today.
It's a pleasure.
And Dr. Omar Shlomovitz is the classically understated co-founder and head of research at Zengo. Omar is deeply active in researching and assessing the integrity of security protocols and practices, and he's an avid contributor in the open source community. And again, he's a co-founder and board member of the MPC Alliance. So Omar, thanks, and I appreciate everything from both of you guys for joining today.
Thank you.
So MPC is a technology that's been around for a long time, and Dan, you know, on this group, you clearly have the deepest experiences with that. Would you mind kind of giving folks kind of a brief introduction to the history of MPC?
Sure, Frank. I would say that the technology got its early fundamentals set up in the 80s already. Then we got the first ideas, like the designs of how could you emulate digital circuits. Like you can imagine electronic circuits, but how you could do them in a sort of encrypted way in computers, so you could run programs which wouldn't see the data. So that was one of the initial attempts back then. In time, we also learned about new ways for doing encryption, things like homomorphic encryption, and the new ways for doing MPC. MPC standing for multi-party computation. Effectively, you can think of it as a homomorphic encryption run by a number of parties together. There were some key moments in the 2000s when the researchers were able to demonstrate MPC in actual practice. Because before that, for 2 decades, it was mostly an academic subject. But once it had already been demonstrated once, other teams quickly followed, and we had the first applications, we had the first real world use cases, and then this got the ball rolling real quickly. And by the late 2000s, we already had uses of MPC to run price auctions. We were doing industrial benchmarking between companies. We were doing fraud detection, bioinformatics. The use cases started piling up, the papers started piling up, but industry adoption waited a little bit longer. And I would argue that around 10 years ago, we really got going in that regard as well. And over the last 5 years, there has been a significant growth in MPC companies. There's a lot of startups. Some of them already started earlier, but now we are really getting going. And that is very much thanks to the great growth in digital assets and digital systems, the whole converting one's systems to better security, building privacy in, building these sort of private by design systems, and understanding that single sources of control over data may not be the best architecture going forward. One also has to mention the blockchain technology and its role, because some of the things that blockchain has enabled have also been benefiting MPC adoption, because while blockchain is great for integrity, confidentiality is something that MPC excels at. So that is a short, really abridged version of how we got here. And I'll give it back to Frank for an explanation of how we do this.
No, that's excellent. I appreciate that, Dan. So what I'd like to do next is basically walk through what I'll describe as a classic oversimplified example of how MPC works, just to kind of set a baseline to make sure that we're all in sync with exactly what MPC brings to the party in basic concept. One of the classic example is we've got 3 engineers, Alice, Bob, and Charlie, and they're all curious on where their salary sits relative to their peers. And so they all want to figure out what's the average amongst themselves, but none of them want to share their private information with one another. And it turns out MPC is a perfect way to solve this problem. And this application is a great way to illustrate the basic concepts of MPC. So using the principles of MPC, Alice simply shares her, or takes her salary of $120,000 and adds a relatively large random number to it. Let's just assume it's $875,500. And so that the total of those two is $995,500. She then shares this computed number with Bob. Now, Bob can't really conclude anything from this number because he doesn't know what positive or negative random value Alice used. And so Bob then adds his salary of $105,000 to that to come up with a combined output of $1,100,500. And he shares that output with Charlie. Now, once again, Charlie really doesn't know anything about Bob or Alice's salary. And so he then adds in his salary of $96,300 to this amount for a total of $1,196,800. And Charlie then shares that computed output with Alice. So at this point, Alice has the total value of everyone's salary plus the random number that only she knows. So what we would do then is have Alice subtract that secret random value from the total to come up with the net of $321,300. And she could either then divide that by 3, since we've got 3 engineers' salaries, or she could just share that combined total with all the other parties and let them do that division by 3 on their own. And we can talk a little bit about why you might consider things like that later in the conversation. But the parties involved in the computation learn nothing about the other party's secrets except for the resulting average salary. And this assumes that there's no cooperation, between any of the parties where Alice doesn't share the random value or anything like that. So we're assuming in this simplified example that information is kept private. And there are things that you can do that make the example far more complex to manage against the risks of if one of the parties colludes with another, that type of thing. You can still derive the output and keep everything confidential. But in this basic example, the parties involved in the computation learn nothing about the other party's secrets except the average salary. And even better, no trusted third party or specialized appliances or centralized or physically secured, trusted third party is required. Security and privacy are really achieved through the process of this distributed multi-party computation. Now, this again is an extremely simplified view, and you can poke holes in this very simple example. But the actual implementation of MPC follows these basic concepts, but with much more depth and rigor in the process. But this same concept of secret sharing and distributed computation can be used to solve a wide variety of problems. And one example, as we just saw, was the collaboration between these multiple parties without requiring them to disclose their private data to one another. Another example is to protect a secret such as a private key, which is used to secure data or digital assets. And in that case, the private key would be represented as secrets held by these different parties. Gentlemen, let's just open it up and take it from here. Any comments or follow-on statements that you guys would like to add regarding that overview? Yeah, Dan.
I would like to just stress that while this simple example might feel like a very toyish thing, then the actual technology is much richer and is not limited to just calculating sums or differences or averages. You can run machine learning, AI, you can run a variety of data applications and key operations using MPC. It's just that understanding the whole concept of calculating something jointly in partnership is something that has to be understood. And that's why we have been using this simple example to convey the concept of MPC.
Yeah, it's funny because I remember that founding the MPC Alliance, we needed to set interviews with all of the companies that, that eventually joined. And taking this toy example by Frank and comparing it to the real world applications of MPC that we saw, I mean, the vastness of the different use cases, it's simply mind-blowing. But what's important to note is that they all follow the same principles, like this toy example, right? So we have, let's say, two guarantees. One is the correctness of a computation. Eventually, we want to compute a function, and it was shown a long time ago that MPC can achieve correctness, or we can compute in MPC any function we want, basically. And the other property we want to guarantee is this input privacy, right? So in Frank's example, it was this salaries, but it can be many other things. As we said, it can be private keys, it can be some other private information. And looking forward, I expect, just more and more use cases, as we see now in the blockchain space. Many, I would say even most of the companies, by the way, in the MPC Alliance, we have, I think at least half of the companies are coming from applications that are related to key management in blockchain. And it's not by chance, right? So we see many companies or many ways that you can do key management in a smart way, in a safer way, by leveraging MPC. And this is becoming kind of the state of the art, becoming the standard in many cases and scenarios in key management. And I expect to see more use cases that are becoming such killer applications also in the privacy aspects of MPC. As Dan mentioned, we already have it in machine learning and AI, and there are just many examples. I also see that there are some a lot of work now on extending MPC, to run it at scale, right? So remember, it started in theory, something that works nicely on paper with some given complexity. But now it's becoming part of a real-world application, and it means that it needs to behave well under different scenarios, and in particular, when you scale specific parameters. And towards that, I expect we'll see MPC frameworks that just compute any function start to be used and adopted, and we'll see MPC, there's a concept of an MPC ceremony, right? When you want to run MPC once, just to get some secure parameters that have these guarantees of private input. So we'd see just ceremonies with like many thousands of participants, which is amazing to think about this as a distributed computing. And again, like variety of functions and so on. So I'm really optimistic, starting from this toy example and drawing this vector towards what we see now in the MPC Alliance and all the way to future use cases. I'm like extremely excited about it.
No, I think, yeah, go ahead, Dan.
There's also something that we have to talk about, and that's legal and compliance. Cross-border, cross-organization collaboration is something that might benefit hugely for MPC as well, especially given the recent regulatory developments in the world, where data transfers between countries are in a strange situation, but certain data protection authorities have been finding MPC, so this sort of split collaborative processing with no single controller, as a way of enabling these kinds of applications in the future. So there might be a future where certain applications can only be done using MPC-like technologies.
No, those are all key points. And I think, as you're highlighting, Dan and Omer, there's a variety of different drivers. And one of the things that I find interesting about MPC is not only does it introduce a new way to improve privacy and improve security, but it also often provides new opportunities for how you solve problems and actually introduce new capabilities, or at least unencumbered capabilities that were impractical before. As you're describing with regulatory and compliance and that type of thing, and as we have examples later in our application pitches. I think, Dan, Cybernetica might be speaking about healthcare and some of the applications there. It's just rich in potential. It's still early days, but we have seen a real surge in market adoption. And Omar, you highlighted blockchain, which is, a force in its own that's evolving and maturing and becoming a profound part of the future. But we've seen literally hundreds of companies begin adopting and using MPC in blockchain-related applications, and initially around the key management and protection side, but we're also seeing it in the privacy side as well, often integrating directly with blockchain to get that, both the integrity and the privacy aspect that you were highlighting, Dan. But yeah, it's really interesting times, and it's still early days.
We also see, maybe you guys know even better than me, but the big companies, Facebook, Apple, Google, starting to use MPC to commit to MPC, and like you said, in opening up some applications that were not possible before. I mean, on the advertising, Apple recently had this effort on child abuse protection. This is all MPC, and it requires a lot of effort, and it's really nice to see how it plays out. Also, importantly, it's being published in a sense, like you see the details, you see in many cases open source code, so it's great for the ecosystem in general.
Yeah, we're having these large organizations lend their name to the technology, show that they are working on this, even if it's in their R&D labs. Just a few weeks ago, Bosch, the company that you might not immediately relate to digital services or MPC, also showed that their R&D lab has been coming out with an MPC framework. So that is really a technology that is picked up not only by the digital sector, but also people working in Internet of Things, devices, and other kinds of organizations. So there is an interesting time to be a privacy engineer right now, for sure. And these, I hear, are also in high demand on the job market.
Indeed. So I know that in today's sessions, we're not going to go heavy into the mechanics of how MPC works in these specific applications. But Omar, do you want to go through some of the basic concepts of how MPC can be used to help manage and protect keys to ensure the security of the assets that are being protected by those keys?
Yeah, sure. So I would try to focus here on key management, and I would even focus more on key management for blockchains, right? Because there might be some more general view that we can take on key management, HSMs and how we can replace them, and etc. Now, in blockchains, the situation is on one end easier because the blockchain dictates the kind of cryptography you need to use or the kind of functions that you need to compute, and if you want to do it with MPC, so this is what we aim for. So in general, threshold cryptography, you can look at it as part of multi-party computation that deals with the specific functions that are cryptographic in nature. And the function that is relevant in the case of blockchain is the signing, right? So when you do digital signature, this basically allows you to broadcast some kind of a message that is, or a statement that is related to your identity. So this is something that needs to be tied with specific key. And the way that it was being done before MPC is that with just public key cryptography. So you have your single key that you generated, hopefully locally, and then you use it to sign, and then anyone can verify it on the blockchain. With MPC, you can get much better properties from such a thing. So first of all, you can distribute the generation of the key. So instead of having one private key, you can have an access structure or some kind of an access policy around this key, which is fantastic in terms of security, right? So you can imagine like an access structure, like 5 out of 7 parties needs to participate or something like you have 7 parties. And then what you do is that you are able, with using threshold cryptography, you are able to sign, but without ever assembling these shares of the private key in one place. So everything is distributed, it stays distributed, and it allows you to have this kind of nice decentralized or distributed trust when you do the signing operation itself. And it gives you also this benefit of recovery. So as I said, if it's like, I don't know, 3 out of 7, it gives you many ways in which you can recover in case something happened to some of the key shares of something, of one of them is stolen, or even more than one. What's nice, or most important perhaps, is that the footprint on the blockchain is the same, like in just regular signature. So you don't need to pay any, it's not costing you more in terms of the space that you are taking on the blockchain, and also translates to fees that you need to pay. And also it keeps private the access structure that we just discussed, right? So you cannot infer from the signature, you cannot understand what was the access structure behind it. So this is a very efficient way to do something that in blockchains traditionally was called multi-signatures, doing it by using math instead of building on top of resources consumed from the blockchain.
Now yeah.
To follow up on that in a way that even if you don't have 5 or 7 parties, then you can also imagine a client-server system, like a 2-party system, where a key is split between the 2 parties, and you're giving signatures, digital signatures, or you're authenticating using the similar technologies. And there is also precedent in large-scale rollouts where you have, I think the split key authentication and digital signature system has about 3 million users today, and that is based on this exact technology.
Yeah, yeah. Well, I know, Omer, you're with Zengo, and you guys have been very active in the wallet side of blockchain applications, and CPR, who is my employer as well, is also very active in key management for wallets and other applications. And about half of our MPC Alliance members, roughly, are using MPC in the application of key management and protection. And the other half are focused more on the privacy side. So Dan, maybe you could take a moment. I know Cybernetica has been very active in the privacy domain for years in general, and using MPC in particular. But maybe just a quick overview of how MPC is applied. We've talked a lot around it, but maybe some of the specific examples of how it's being applied and how it works, et cetera.
Sure. There are multiple cases for that. First of all, if you have 2-party collaborations, if me and Omer, we wanted to collaborate, compute something jointly, assume that I'm an advertiser and Omer is a retailer, then together we would like to know whether Omer is getting any more sales from the ads that I'm sending his way. And Omer would want to know if the money he's spending on the ads actually is giving him anything. So that's one example of a way where both sides have part of the information, but if it would be put together, we would know a lot more about the value chain of both of our organizations and the service that is being offered. So first of all, there's this 2-party cases. There's also set intersections, like how many customers of mine are customers of yours and things like that. Then there are the more distributed cases. And it doesn't have to be a 2-party thing. You can have hundreds or thousands of millions of data providers. You can build data marketplaces where one party uploads a full data table, multiple records, multiple rows, could be test result, could be a trial result for a new drug, could be something for credit scoring, like his credit history of a certain organization. MPC can be used to link these records together in a fully secure way so that you don't have simple re-identification attacks. It's much better than pseudonymization. It's much better than statistical anonymization, because the attacks that would work on pseudonymized or statistically anonymized data just don't work. They just bounce off of the cryptography that MPC is using. Yeah. In that way, MPC achieves what you would call anonymous computing, because you can't get access to the individual records and you can maintain that policy in a distributed manner, that there is no one single person who is able to recover the secret data, for example, to decrypt. You can make it a distributed role so that a group of organizations who is distrustful of each other, you can just imagine, I don't know, a number of hedge funds on Wall Street who want to calculate the prices of a new asset or something like that. They might not want to share everything, but together they would again create a joint value chain, a partnership, and MPC allows you to do that.
Perfect, perfect. Well, I know we've got a lot to cover today. And next up, we've got Dr. Nigel Smart, who's going to walk through and compare MPC with other privacy-enhancing technologies. But before we wrap up, any closing comments or remarks? I know we've covered a lot of ground, but just a quick check. Anything that you wanted to say that we didn't get to yet?
I want to say one sentence. Sorry, then. MPC is an advanced. It's within cryptography, which in itself is considered difficult, relatively hard field in computer science. MPC is advanced form of cryptography, and if you want to go down this rabbit hole, it's not something usually that you can get a hold of, in a day. It takes time. There's a lot of layers to cover. It's fascinating, I think. And I encourage you all, to learn more. And I think we provide in MPC Alliance the resources you need to get started. And be in touch if you want to learn more.
Yeah, that's excellent. Dan?
Following up to that, the thing is that you can put MPC into a lot of information systems. You can imagine that if Apple is deploying MPC, or should Facebook deploy MPC, then it will be hidden behind a nice button, so the user experience wouldn't change a lot. So you won't see the nitty-gritty when you're actually using it. It can be hidden into the system so that it becomes more secure, but the system is still the same, similarly useful.
Exactly. Ultimately, the user experience, the user should never know or care that MPC is running in the background, right?
And that's when we win. When it's just when every system is secure by design from inside, then I think we have reached our vision.